Hello class. In this lesson we're going to learn about inscribed angles. And if we're going to learn about inscribed angles, we have to also learn about arcs. And an arc is just a part of a circle. And there are three different types of arcs we can have. We can have a semicircle, which is where the endpoints of the arc are the endpoints of a diameter. We could have a minor arc, which is where the endpoints of the arc aren't a diameter, and we look at the smaller part of the circle in between them. So minor arc AB goes from A to B, this red one. A major arc is what we get if we go the longer distance. So this blue one, major arc ADB, is the corresponding major arc with the same endpoints A and B. So when you name a major arc or a semicircle, you have to use 3 points so that we know that we're talking about the larger one. If we just use 2 points, we're assuming we're going the shorter distance in between them. So we also have inscribed angles, which is an angle in a circle where the vertex lies on the circle. And we have intercepted arcs. And to get an intercepted arc, you look at where it hits the circle. So not where the vertex is, but where the other two are. And those define an intercepted arc. And we can have intercepted arcs for inscribed angles, central angles, all types of angles. We're not just limited to inscribed angles. So let's see if we can see a connection between the central angle here, CAB, and the inscribed angle. Now in this case, one of the sides is a diameter. And what do you notice here? What's special about angle CAB? Well, it's an exterior angle of triangle ACD. So we know its measure must be the same as the sum of the two remote interior angles. So let's see if we can figure that out. What's special about this triangle over here? Well, it's isosceles because these are both radii. This is isosceles by the base angles theorem. We know this angle over here must also be x. So to find the exterior angle, you just add the two remote interior angles together and we get 2x. So in this case, the measure of the central angle is twice the measure of the corresponding inscribed angle with the same intercepted arc. Now let's look at an example in GeoGebra. So if we look here, the inscribed angle is 42, and the corresponding central angle with the same intercepted arc measures twice that, 84 degrees. Now what happens if we move this vertex to another point on this major arc? Well, that angle measurement isn't changing. Is that a coincidence? Let's look at another example. Let's change the numbers up. So here the inscribed angle is 56, and the central angle is 112, which is twice that. And if we move D around this major arc, it still measures 56 degrees. That doesn't change. So it's looking like this holds. And it turns out that that is always true. This is called the inscribed angle theorem. Now, we only showed one case of it, but the other cases hold as well. We just saw when the inscribed angle had a side that it was a diameter. So we can think about this two different ways. We can say that the central angle is twice the measure of any inscribed angle with the same intercepted arc. Or looking at it the other way around, you could say that an inscribed angle has half the measure of any central angle with the same intercepted arc. So let's look at some applications of this theorem. So we're looking for x in all these examples. If we look at letter A, they give us the measure of angle D, which is 25 degrees. That's an inscribed angle, and x represents the measure of a central angle. So it has to be twice the measure of the inscribed angle, so that must be 50 degrees. Now in letter B, we want to figure out what angle C measures. They tell us angle D is 15 degrees. Well, this is kind of similar to our example we looked at before. This is an isosceles triangle because these are radii, so the base angles have to be the same, so that must also be 15. And letter C, what do we have here? Well, this inscribed angle intercepts arc BC, and so does the central angle BAC, which is a right angle. So the central angle measures 90 degrees. So the inscribed angle is going to be half of that. So it has to be 45 degrees. Now we got a few extra steps in these, but we're still applying the same ideas. So we want to figure out what x is, and we know b is 32 degrees. Well, if we know what b is, then we can figure out what a is, because that's a central angle with the same intercepted arc, CD. So the central angle is going to have twice the measure of the inscribed angle, so that must be 64. Now, this is an isosceles triangle. These are radii. So that means that C and D are both, or angle ACD and ADC, both measure x. So if we take 180 and subtract the vertex angle from it, divide that by 2, we get what the base angles are. Now, if you don't like this, you could always write an equation and do the algebra. You would have x plus 64 equals 180, and you get the same answer. Now, in letter E, they don't give us any numbers directly, but we can deduce what the measure of W is. So W, well, what do you know about these W's? They're on the diameter, and we know that since they form a straight line, that they add up to 280 degrees. Oops, that was for the other one. So if we want to get 1W, we divide by 3, and we get 60. And what do we know about X? Well, X represents the measure of an inscribed angle. And if we look at the intercepted arc, DC, this is the corresponding central angle. So the central angle measures 2W, which is 120. And so the inscribed angle is going to be half of 120, which is 60. So here they give us the measure of angle D, which is 19. And we want to figure out what X is over here. So this is kind of similar to what we did in example D over here. So we're looking for this base angle over here, right? Because this is an isosceles triangle. And so the vertex angle is going to measure twice the measure of the inscribed angle. So double 19, and we get 38. So the same idea as before. We subtract this from 180 and divide by 2, and we get 71 degrees. So Toby thinks that triangle BEA is a right triangle because angle BEA measures 90 degrees. Is he correct? Why? Well, let's look at what we can figure out here. Angle BEA is a vertical angle with angle CED. So these have to be the same. So if we could figure out what the other angles are in this triangle, that'll tell us if this is 90 degrees or not. So what can we say about angle BCD? How can we find its measure? Well, it intercepts arc BD as the central angle EAD. So it has to be half of 70, so that measures 35 degrees. And so we know that these angles add up to 180. So that means angle VEC has to be 95. So that means that our vertical angle here is also 95 degrees. So he is incorrect. That would actually be 95 degrees. So here you have a quadrilateral that's inscribed in the circle. And we want to figure out, are the opposite angles supplementary? We also want to write each of these in terms of the other variable. Well, let's add in a central angle here. So here's a central angle. And we have one on this side that corresponds to the inscribed angle with X, and one that the reflex angle here I labeled with the red arc that corresponds to the inscribed angle with Y. So let's see, we know that the central angle here has to be twice this one, so this one must have a measure of 2x, and this one will be 2y. So what can we say about these angles? What do we know that they add up to? Well, these are angles that form, that at a point, they go around a full circle, so they add up to 360. So 2x plus 2y is 360. And if we divide everything by 2, we get x plus y equals 180. So yeah, they're supplementary because their sum is 180. And so to write one in terms of the other, we could just subtract one of the variables from both sides, and we get our conclusion. And in this one, we want to know what the measure of angle WXZ is. Well, these are two inscribed angles that have the same intercepted arc WZ. So they have to have the same measure. And if you don't believe that, you could always draw in the central angle here. And we know that this would be double 72, 144. If we're going to go to this inscribed angle, we just divide it by 2 to get 72 as well. In this lesson, we learned about inscribed angles. Thank you for watching this video.